Hi students, this is Mr. Yao. Today we're going to talk about 2.5, where we will learn about compound inequality by using the word or. So last week we have learned about intersection, or the word and. So this week for or, that is called union. The symbol is this capital letter U shape symbol, so that's representing the union. When several inequalities are combined by the word or, which means one or the other or both. So in comparison, last week when we did intersection, it just means and. The union inequality is formed and is worked out as two separate inequalities and then graphed on a common number line. Union inequalities, however, cannot be written in compact form. For last week when we did intersection, we can always write compact form. When we get to an example, you will see why we cannot. Here's example 1. Let's graph them separately first. So x is less than or equal to negative 1 right here, pointing to the left, and then 4, open circle, pointing to the right. If I have the word and, that should give you no solution because apparently they're not overlapping. However, here's the word or. Let's start shading and see what's going to happen. For the first one, it's going to be right here, including the negative 1. And for the second one is going to be right here on the right side, but it's still an open circle on 4. Remember, the word we emphasize on is one or the other or both. So as long as the number appeared somewhere in the shaded area, that means that will be the answer, that will be the solution. So in this case, when we actually put together the shades, it would be everything on the left side and everything on the right side. So when we write the final answer, based on the new graph in red, we are going to write it as less than or equal to negative 1. In the middle, a union symbol, and then x is greater than 4. That will be the final answer. Again, as long as they appeared, so one or the other or both. Example 2. Same idea. Let's start graphing first. Negative 1 pointing to the right, 4 pointing to the left. And let's start shading again. For the first one, I'm shading everything to the right of negative 1, including the negative 1, and again here just emphasizing including that 4. Then for the other one is everything to the left of 4. And for our final answer, we are looking for any part that has been shaded. So starting from the left side, shaded, 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 still shaded in the middle, still shaded, still shaded, still shaded to the right. Everything is actually shaded, which means the final answer is going to be all real number. And the reason is any number would actually make this whole thing work. They will appear in one or the other or both. So final answer, all real number. You might be curious about that 4. You're like, wait, but I see an open circle there. Let's look carefully. If we just look at the orange part started from negative 1, and anything to the right side of negative 1 would be included. So there actually is a dot on the 4, which means 4 is being shaded. So when I count any part that is shaded, it also includes that number 4. That's example 2. Next, example 3. X is less than or equal to 2. Less than or equal to 2. And x is also less than 5. So I'm going to start shading the 2 first. That's going to be this part. Then I'm going to start shading the 5, which is anything to the left of 5. So no matter what, it wouldn't be all real number because there's nothing to the right side of the 5. Which means, finally, when I shade any part that's being shaded already, will be everything over here. And based on that graph of the red color, the final answer is x is less than 5. Because it's to the left side of 5, that is still an open circle, so x is less than 5. Number 4, 1 to the left, 6 to the right. Shade both the outside. Final answer, x is less than or equal to 1. Union, x is greater than 6, because we are going to keep both. That's example 4. Example 5. So the steps are very similar to solving intersection, with one little exception. Instead of looking for the overlap, we are looking for any area that is shaded on the graph. Let's solve them. Add 5 on both sides. 2x is greater or equal to 8, so x is greater or equal to 4. Subtract 4 on both sides, so 3 is greater than x. Then we need to make sure the x is on the left side, so they switch. X is less than 3. Less than 3, greater or equal to 4. So shade both the outside. Final answer, x is less than 3, union, x is greater or equal to 4. Preferably putting the smaller number on the left, in the front. So that's how we write it. Number 6, the steps are the same. However, this time be careful with the negative sign. So first we're going to divide both sides by -5. That's gone, but we need to flip the sign because we did just divide both sides by a negative number. So it's less than or equal to -4. The other one, add 3 on both sides, so -5 is greater than -x, then divide both sides by the negative. So that means I need to flip the sign, x still on the right side. Now I need to switch them, switch the x and the 5, so x is greater than 5. Greater than 5, less than or equal to -4. Shade both the outside. Final answer, x is less than or -4, or x is greater than 5. That's number 6. Number 7. Now this is the first special case. Let's have a look. I add 1 on both sides, -10, n is less than 0. Divide both sides by -10, n is greater than 0. For the other one, add 2 on both sides, so 0 is less than -3n. And switch the left side and the right side, so -3n is greater than 0. Divide both sides by -3. I got n is less than 0. Again, 0 divided by anything is 0. So now let's start graphing. The first one, open circle, left side. The second one, open circle to the right. Now let's start shading. For the first one, I'm shading this part to the left, emphasizing on that still being an open circle. Then for the other one, I am shading everything to the right of it, emphasizing again on the open circle. So no matter which side I chose, I never actually circled the 0. I never shaded the 0 at all. So when I look for any part that is shaded, well, I started from the left side, shaded, but the 0 is not shaded, but it still extends to the right side. There are two different ways to write it. You can either write it with n is greater than 0, union n is less than 0. That is one way. Or you can say all but 3. Not 3, but 0. That means all real number except 0. So that's the first special case, number 7. Number 8, now we're working with some fractions. So the first one, we're going to need to get rid of the denominator, so multiply both sides by a 4. That is 2x plus 3 less than 8. So 2x is less than 5, x is less than 5/2. Now the other one, subtract 3 on both sides, or actually multiply everything by 15. So that's -15x over 5, so -3x. And 3 times 15 is 45. And the last one is 30 over 5, which is 6. So -3x is less than, subtract 45 on both sides, -39. Divide both sides by -3. X is greater than 13. So less than 5/2 and greater than 13. So I shaded the part. Final answer, x is less than 5/2, union x is greater than 13. That is number 8. Number 9, here's another special case. First, subtract 9 on both sides. Got negative 5, v is greater than, well, actually, we're going to subtract v first on both sides. 9 minus 6v is greater than 9. Now minus 9 on both sides, negative 6v is greater than 0. Divide both sides by negative 6, v is less than 0 because we are dividing by a negative number. The other inequality, subtract 2v on both sides. Negative v minus 10 is less than or equal to negative 10. Add 10 on both sides. Negative v is less than or equal to 0. Divide everything by negative 1. So we got v is greater than or equal to 0. Now let's start graphing. That is not going to be a 6 actually, that's a 0. Okay, now let's start graphing. The first one, less than 0. And the second one, greater or equal to 0. Now let's start shading. For less than 0, shading everything, but I still gotta keep the open circle. And then for the right side, I'm shading, but now I actually need a solid dot in the middle. Let's think about it. When I shaded the left side, I actually didn't shade the 0. When I shaded the left side, I didn't shade the 0. However, when I shaded the right side, I did actually shade 0. Since in our final answer, we're looking for any part that is shaded, starting from the left side, and 0 is shaded, so including the 0, shaded all the way to the right side, and final answer, all real number. That is number 9. Last one, number 10. That is another special case. Subtract 3k on both sides. Negative 2k minus 3 is less than or equal to negative 7. Add 3. Negative 2k is less than or equal to negative 4. Divide both sides by negative 2. Co is greater or equal to 2. For this one, however, well, that first one is easy to graph. So I'm going to graph first one, greater or equal to 2. However, for the second one, subtract 5k on both sides. That is gone. Then we got negative 4 is less than or equal to 3. Well, there's no k left, so I can't exactly graph for k. However, if you look carefully, that is negative 4, and this is being read as less than or equal to. So I'm asking you, negative 4 is less than or equal to 3. Is that true? You might be thinking, the equal sign may not make it true. But it's actually the sign is using the word or. That means I just need to satisfy one of them, then it would actually be true. So negative 4 is actually less than or equal to 3 and will always work without any concern about k. So I can basically give k any value, this whole equation, this whole inequality would still work. It will always work. Which is why for the second inequality is specifically, the answer would be all real number. So I'm gonna change the color for the first one. So I shade the first one, that means I will be shading this part. But I'm shading the second one, which is all real number. That means I am shading everything that is a real number. So finally, when we need a shade for the answer, anything that is shaded is going to be an answer. So final answer is still all real number. That is the special about number 10. That is everything for 2.5. Thank you.